Here, if you differentiate, suppose, what is the formula for volume of a sphere? 4 by 3 pi r cube. Just differentiate it with respect to r. What is that? And that is what the surface area. What is the formula for surface area? 4 pi r. So every time one layer is adding at particular instant, if you want to say that what is the change occurring at that particular moment, you simply say that is the surface area, that is the one layer at that particular moment. Use of derivatives. Now, again, use of derivative is simply say it is used there, it is used in stock exchange, it is used in there, but students don't get any chance that they feel that yes, it is used. They have to use derivative to do certain things. So this can be a very simple example. For the last many years, there is one question in the exercise, that is what? There is one question in the exercise, that is if you make an open box by cutting square from each corner. That question is there, but now this can be used to explain students the use of derivative, because it is in part of application. Here I have given one sheet of paper to all the students that you try cut square from the corner, whether 1 centimeter, 2 centimeter, 3 centimeter, and make open box. Give me one open box which will be of maximum capacity. Which will have, so this is a shopkeeper who wants to make these boxes. He wants to make that box which will contain maximum objects. So for that, as this is the one example, that from each corner cutting. Now you see, if cutting once, suppose let us have an example of 10 into 20, 10 by 20 sheet, if you cut 1 centimeter, then what will be the volume? 8 into 18 into 1, that is 144. If you take 10 into 20, cut 2 centimeter, that means 6 into 16, 96, 96 into 2, that is 192. If you cut 3 centimeter, it is coming 160. So from 144 to 192 to 160. So from, it is like a curve which is from one level it is increasing, and after certain level it is becoming decreasing. So can student answer you that at what point they will cut the square to get the exact maximum volume? Either they will hit and trial, but for paper sheet they can hit and trial, but how for long sheets and other sheets? How hit and trial? They are again not going to find the exact value, but that application of derivative, maxima, minima, that you can use here, and let the students have, suppose this is 80 by 30, simply by derivative. They are doing these questions so many years, every year teacher is doing this question. But to visualize the use of derivative, they will have a feeling of that, yes, only derivative can give them the right value, not by hit and trial. The exact value will be given by simply considering this result, application of derivative. Integration also can be in the same way as I am giving the examples of differentiation, same way you can for derivatives also. And very simple, we always say that at the corner point, the derivative is not occurring. Whenever there is a corner point, as here in the graph of this mod x, there is a corner point. So why at corner point there is no derivative occurring? Function is continuous, as we say all mod x is continuous, but not derivable. So simple, we made a model in our laboratory and we kept one rod here, because this is a point. And if we are talking derivative at x is equal to 0, that means we should have a unique tangent at x is equal to 0. So by putting a rod, a moving rod here, and passing through this, and it slides, it moves from here to this position. Every position it is passing through that point, and all have different slopes. Here, in this case, particularly here, it is slope is -1, slope is +1, and in between anywhere because all the lines will be passing through this point, means we can have infinite number of tangents here. At any corner point, because a point we can have infinite number of tangents, so derivative will not exist at that point, more than one slopes. Or very simple, I have given at all corner point, the function is not derivable. Why? Because as I have shown you that at the end point, where to move, next what will be there? If there is no movement, how we can find the slope? So this is what I have given you certain examples, but these are the examples, these are not the all examples. You can think, teacher can think in this way to explain the abstract concepts and use these real life examples to explain the nature, that is whatever is occurring, and relate it to the abstract mathematics, the mechanical process what we are doing in the classroom. Instead of that, we should give certain daily life examples. Lot of examples we can give. You can explain why x cube, why change, if you differentiate it is coming 3x square. Why 3x square? Physically you can show that x cube, you take the cube, one surface at the top, one on the one side and third side. All three surfaces are changing, because if you change x, it will increase length also, it will increase breadth also, it will increase height also. So in three surfaces there will be change. So 3x square. If you make two variable, length and breadth are variable, and height is constant, then L plus delta L, B plus delta B. The product rule you can explain simply keeping the height constant in a simple pack of sheets, and just L slightly more length, L plus delta L, B plus delta B, and then show that L into delta B plus B into delta L plus delta L into delta B. Delta L into delta B very small, so that will be very negligible, tending to 0. The change is very small, but the derivative is, as product rule, can be explained simply by taking this physical example. So lot of examples are there in which we can relate our teaching with the daily life. In simple integration, if you see the reverse of it, the integration, how integration? If we talk of the volume of cylinder, just integrate pi r square, one sheet of CD disk, you can say disk, and go on adding this 0 to h. Integrate 0 to h pi r square means we are keeping one CD, then other CD, then other CD. 0 to h pi r square, you integrate this pi r square h. So the reverse process can also be explained. Whatever you consider, if you explain differentiation by giving these examples, the reverse process integration. Suppose you want to talk surface area of the cylinder, you go on adding rings 2 pi r. Integrate 2 pi r from 0 to h. Just go on adding rings, and they will have an idea that if we are adding rings from 0 to h, the integration is 2 pi r h. The surface area, if you just put one bangle, another bangle, another bangle, another bangle, it will become the surface area. So this can give them the idea of, from what they know. Actually, calculus is for also not only for uniform things, for other things also, but from simple things we can just introduce the concept that what is the meaning of integration, what is the meaning of differentiation, and then they will have an interest. They are studying derivatives, but they are not knowing what is the use of it. So once they have one simple example with simple activity that they have done in the classroom, that yes, only this derivative gives us the exact value. So they will have more interest in studying calculus. Thank you very much.